Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day pulled from an educator site on the SAT website, and it may be on a Blue Book test, so that is a spoiler alert. Okay. Two times the quantity in parentheses, kx minus n, close parentheses, equals negative 28 over 15x minus 36 over 19. In the given equation, k and n are constants, and n is greater than 1. The equation has no solution. What's the value of k? Oh, this is matching coefficients. But wait, can't we just... Oh, well, first of all, the coefficients in front of the x have to be the same. So let's make sure that that's true. So let's see what that gives us. If the equation has no solution, that means the slopes are going to be the same, and they're parallel lines. So let's at least see what this tells us. We know that negative 28 over 15, because that's the coefficient in front of the x, has to equal 2kx. Oh, wow. Wow, look at that. That just gives it to us.
The coefficients.
2k, right, 2k.
Good.
I don't know why this is so sluggish today. Equals 2k.
So k is half.
That gives it to us. That just gives it to us right there. We don't have to
k is half of that negative 28 over 15. Right. So it's negative 14/15.
Why is this so sluggish today? K equals, yes. And I'm having technical issues. Negative 28.
That you can, that you can simplify to 14/15.
Negative.
Yeah.
14/15. Yep. That looks right. Yeah.
You can do the arithmetic really quick by noticing 28 is even.
Oh, yeah. Then you can cut 28 in half immediately. Right, yeah. Wow, so this is a surprise because n had nothing to do with anything. Unless we're missing something. It's a little suspicious. I mean, this is supposed to be a difficult question. Oh, my God.
Well, if n is such that minus 2n equals negative 36/19, then the equation has infinitely many solutions. When the value of k is picked as you picked it, if n happens to be such that the constants on the left-hand side and the right-hand side are the same, then the equation simplifies to 0 equals 0, which has infinitely many solutions.
Wait, but first of all,
however, the key thing in solving this problem is the information that the equation has no solution.
Right.
You don't need to the statement that n is greater than 1 is unnecessary.
Well, first of all, I must say that my computer is extremely sluggish. I have a problem with the internet, so hopefully we don't have to record this. That's why I look a little funny and everything is screwed up with me today. So that's peace out. But I'm suspicious. In order to have no solution, then the constants have to be different, don't they? The constants have to be different, and the constant
on the two sides,
yeah, the constant on this side is negative 36/19. We know. Well, let's see what the constant is here. Well, it's
minus 2n.
Oh, it's minus 2n. But n is greater than 1. So when n is 18, wait.
And n could be
18.
N could be what could n could be? N could be 18
over
19ths.
but it's exactly, it could be 18 over 19ths, but that makes
Yeah.
it less than 1.
Yes, yes, yeah.
Right. So
However, what they could do is say n is fixed but unknown,
yeah,
and the equation has and the equation has no solution.
yeah,
In that case, k is determined. It's the answer. The k it's the negative 14/15, and also n is restricted.
yeah.
N must be different from 18/19. Okay.
So yeah, this question can make one a little nervous in that if you just do it this way, you realize n is not involved, and then it would
Yeah,
take time, like we just
yeah,
did, to verify what is going on. But you're blowing time, and it turns out that
yeah, yeah,
verifying what's going on with n is just wasting your time
yeah,
because this determines it all. They want to know what k is. This is a one equation, one unknown problem. So the only way to get k must satisfy this, right? Because we only have one
yeah,
equation.
yeah. Well, I think maybe it's given that way to help people who follow a more routine thing. The more routine thing is after picking k to be negative 14/15, you could simplify the problem. You could simplify the equation and get that the resulting equation is negative 2n equals negative 36/19.
Right. That's exactly what we
Right
have here.
now, so we have an equation between two constants.
Yeah.
An equation between two constants with equation A, like 3 equals 4, with a variable lurking in the background, has no solution. And the equation 4 equals 4 is true, is true, no matter what any variable is.
Right.
So this has infinitely many solutions.
Right.
Okay? So they're telling you, so if you're led to the equation minus 2n equals minus 36/19, then if you use that n is greater than 1, you'll realize that equation is untrue. And so with that when you pick that value of k, you're immediately led to an equation that has no solution.
Right.
But again, that's going the converse. The idea is that what this problem is, the logic of it is not given k, tell whether it has no solution.
Yeah.
The logic is given that it has no solution.
Yeah.
Find k.
Exactly.
So the logic is if it has no solution, then k equals something, and you can figure that out.
Right. And the n minus
Now, it's
1.
not the case. It's not the case. It's not the case. K equals negative 14/15. Does the equation have no solution?
I know, you already said that.
Right? And does the equation have no solution with the given k depends upon n.
I know, yes, you already said it.
Yeah. So I think this is I think the posers of the question made a logical mistake.
Okay. But I want to ask you a question. Wonder whether they debated this. And by the way, my computer's back alive. I'm going to be okay now. What happens if they said, "What is the value of k?" Or does it is it impossible to determine k? That would have thrown a little quirk in, right? What is the value of k? Or is k not possible to determine?
Are they? With that question you're asking, are you still hypothesizing? Are you still including in the question the statement?
Absolutely.
Yeah.
Of course it is.
Okay.
Of course I am.
Okay. Again, I stand. I stand. If the equation, if the statement is this equation has no solution.
Right.
Right. From that statement alone, you could conclude that k equals negative 14, 15.
Only if n is greater than 1.
No.
Yes.
No.
Yes.
No. No.
Yes. You have to put the n is greater than 1 in.
No.
Oh.
You say the equation equation has no solution. That implies k equals negative 14, 15, and n is not equal to.
Always have the.
So if under the the given that the equation has no solution.
Yeah.
You could make two conclusions.
N is greater than 1.
One conclusion is that k is negative 14 fifteenths, and the second conclusion is that n is not equal to positive 18/19.
Right. Yes. So
basically, if the second statement were true, it is not true, the hypothesis. Because if the second statement were true, it would have a solution. It would have two solutions. It has infinitely many solutions.
Right.
And have infinitely many solutions is logically different from having no solution.
Right. Okay, so in other words, the words here, the equation has no solution, and n is greater than 1. I always make it. So stop. Let me finish talking. Is overly redundant. It's like redundant information. You don't need both. Well, all you need is this. All you need is no solution. You don't need to be told this. But the bottom line is n is greater than 1 and the equation has no solution are consistent with each other.
They're consistent, yes.
They're consistent with each other. Yeah. Okay, enough ranting.
Right.
Okay, so today's Throwback Thursday, so we go back to it. Oh no, we have to look. We're so rusty because we missed a few weeks. We have to do our questions. We have to look at the answer, and then we're going to do Throwback Thursday. So we're here for a while. If you feel like tuning off, see you later. Okay, so the questions. Can you start with the answer? Of course not. They don't give. It's not a multiple choice. How does this question differ from a school question? Teachers will never have this question. So
unless attention teachers look on the SAT website for teachers material and find problems like this to get to your class.
Right. Only the SAT or teachers that model SAT questions will come up with a question like this. This is a highly obtuse type of question. Is there a pattern to this? No. There's nothing specific about these numbers that makes this a pattern. But you certainly have to know that, and this is where the main idea, what's the most important question is, what's the main idea? What are the SAT people wanting to see if you know? You have to know that if equations have either no solution or infinitely numerous solutions, the coefficients of the variables must be the same. And if it has no solution, then the constants have to be different, and if it's infinitely many, the constants in the equations on both sides, the constants on both sides have to be the same. So that's the essence of the question. That's the essence of what they need you to know. There are different ways to set this up, but this was pretty direct. Did I know the question would be this easy or straightforward when I first set it up? Nah, maybe Seth did, but I certainly did. So, should we see how they did it? Okay, oops, okay, so when we kill the annotation, you'll see some other stuff come up. See that? Okay, let's see what they say.
I don't know. This is a weird. Wait a minute. In terms of the equation, the numbers on both sides being the same or different, I don't know. I'm a little skeptical here. Here, what if you do this?
Yeah,
X
I thought I may have
plus
said that too
1,
fast.
right?
Yeah.
Equals 2 times x plus 1.
Like you first have to do order of operations to get rid of those parentheses.
Yeah. So if this has only one solution, right? And the solution is the thing that makes x plus 1 equals 0.
Okay.
Right.
Yeah.
Otherwise, yeah. So generic x. Yeah. So
I said the numbers on both sides. Okay, fine. I meant when the
and those
equations are
2x plus 1 is equal to 2x plus 2. Yeah.
Okay, I hope people understood what I meant. The equations have to be all multiplied out and in standard form. Okay.
Yeah.
Okay. So let's clear that. Let us stop this.
Yeah.
Let's go like this, and let's see how they did it. Oh, wow. Correct answer. Okay. Rationale. The correct answer. A linear equation has no solution when the coefficients of x on one side equal the and the constant terms are not equal. So they said exactly what I just said, except better. More, maybe Seth will agree to that better, which he should. Dividing both sides of the equation by 2. What? But who cares less about the constant term? Since it's given the equation no solution, the coefficient of x on both sides must be equal. Since that is the second condition is true. What, they're asking us to verify their own conditions? And it's given that what?
I think the writers of this made some logical mistakes.
Yeah. You see,
this is I'm sensitive to that because of my education in math, having gotten a PhD in the subject.
Right. Yeah. So we could just introduce ourselves now. I'm Joel. I have a PhD in mechanical engineering. That's why I don't get bothered by this stuff as much. I just want to get the answer and move on to the next question. Says a PhD in math, so he cares about exactly how things are written. Math is very precise when you get math is always very precise, but when you get to the PhD level, you really got to be precise. So, so that's where our education backgrounds are from. Okay.
Yeah, logical mistakes. It says here, given that there's no solution, you could conclude that the constant terms on both sides must not be equal. That is a conclusion.
Right.
Therefore, that second condition is true. It's directly true.
Right. You don't have to verify it.
It's not true because n is greater than 1.
Right. Yeah, that's right.
And in fact, it would be true. It would be true if it would be true for every n, including the small n, less than 1, the negative n. Every n it would be true for, except for n equals 14/15.
No, 18 over 19.
18/19. Yeah.
Okay.
So
Let's
So
move on.
they messed it up.
They messed it up. It
Yeah.
happens. It happens. Okay, so what are we going to do now? We are now going to kill this. We're going to go like this, and we're going to visit a question from over 20 years ago. That's this one. But in order to do this, you just have to excuse us. We need to do some technical changes to our to the way we look to make space for this. So there we go. Wait. There we go. So we are just changing our orientation. Just excuse us while we do this work. And then we go like this. Okay, I think we're in business for the Throwback Thursday question of the day. Seth, do you still see the screen?
Yeah.
Good. Okay, so let's bring in the annotation so I don't work in Zyteboard. And here we go, a question from over 20 years ago. Okay, in the figure above, X, Y, and Z are lengths indicated. And we have a nice little number line there. I don't know, maybe my gut feeling should put a 0 there. What is the arrangement of X, Y, and Z in order of increasing length? At least it doesn't say cannot be determined. Notice there are 5 questions, 5 answers back then, and they took off if you answered the question wrong. Okay, so there's got to be the straightforward way to do this. And Seth, this is your big chance to show off your knowledge of math. Is there a way to take advantage of patterns and get the answer like instantly if you're a super smart, clever person with a high IQ or a lot of experience in math? So anyway, let's stop talking.
Well, I think what you have to do is have to calculate each of these differences.
Really?
A quarter minus a seventh.
And this is
a quarter minus a seventh.
I don't know.
Don't know. What are you doing? A quarter plus a seventh. It's this distance here. The value of x.
Yeah. Oh yeah.
X is equal to 1/4 minus 1/7.
Got it. Yeah.
Y equals 1/3 minus 1/4. And Z is equal to 3/7 minus 1/3.
Oh,
so boy. I have to put these in order.
I forgot whether this is a calculator test. Let's see. This test, it doesn't say. I don't think it's a calculator. No, I don't think there's a calculator back then. So I don't think you're allowed to use a calculator. It's too bad. Because you could do it quicker on a calculator.
Now,
but is there a pattern? Is there a pattern?
You could simplify some of these things. If you want to test, let's see, without using a calculator, what's cool about this is that, see, we want to test, to see if X is greater than Y. X is greater than Y is equivalent to X minus Y is greater than 0. And that's equivalent to a quarter minus 1/7 minus 1/3 minus 1/4. See, is that greater than 0? Well, so this is, you could calculate this using small fractions. A quarter minus a quarter is 2/4.
That's a half.
And then minus a seventh minus a third is minus 1/7 minus 1/3. And this is clearly.
Ooh, that's close.
That is
close. That is close because the seventh.
This is like a half.
The seventh is like.
Well, no. If it were a sixth, if the 7 were 6, it would be 0. But it's really a 7th, so you're subtracting less. So this is greater than 0.
So X is greater than Y.
So X is greater than Y. So you could. So this is possible, and this is possible, and then you just have to check whether what's the difference between here and here? If compare y and z, yeah, you have to see what z is. So so what I would do is compare z with x. And let's see, z with x.
And you have a pattern of 3/7 and 2/7.
Yeah. Z with x. Yeah, so compare z with x. So z minus x.
So if you're writing somewhere, I can't see it.
Okay.
Wherever you're writing,
so z
write it. Yeah, write it over there. Yeah.
Z minus x is greater than 0. Is equivalent to z is greater than x. And then z minus x is greater than 0. Me is again, these are question marks. We don't know. Z is
3/7.
z is 3/7 minus 1/3, and then subtracting x.
No, right underneath.
I heard you. Subtracting x. X is 1/4 minus 7. Right?
And that's great.
And then we simplify this. Okay, well, so it's 3/7 minus a 7 is 4/7.
4/7.
And then minus 1/3 minus 1/4. So it's 4/7 minus 1/3. I hate this. 4/7 minus 1/3 minus 1/4.
That's 7/12.
Is that positive?
That's 7/12. 7/12 is a little bit over a half. 4/7
Yeah.
is also a
Good.
little over a half. Oh God! What are they? Whoa! Look at my God! These numbers are so close to each other.
Yeah.
Wow! 4/7 and 7/12. I mean, you have to use a common denominator, don't you? Of 84.
Yeah.
My God.
4/7 minus 1/3 minus 1/4. Wow.
Yeah. So you need 84. But 84 times 12 is 7. So that's 28 versus 7. Versus 12 times. Wait. No. What am I doing? 4/7 minus 7/12. The common denominator is 84. Yeah. So how many 84s are in 7 is 12, so it's 48. It's 48, not 28. It's 48 minus, and then this is 49, which is not true. So this is not true.
So it's not greater than 0. It's negative.
It's not true, yeah.
So that means x is greater than z. And so this is a little...
No. X is less than z.
No.
Right. This is not true, right? Oh, this is so confusing, right? This would mean x is less than z, so x is greater than z, right?
Oh, so this is wrong. Oh, x. So we've concluded that x is greater than z.
Isn't that right?
All right.
Wait, isn't that right? Because this is not true. So z.
Yeah, not true.
Z
so
x is less than 0.
All right, x is less than z. Yeah, so x is before z in the diagram. So x is great. X is this expresses that x is less than z.
So x is greater than z, isn't it? Yeah. X is greater than z, isn't it?
Yeah. Okay, so we're wrong. Yeah, it's just confusing. Yeah.
So which one is right? X is greater than
X is less than z is false.
Right. So x is greater than z.
So x is greater than z is true because they're not equal. So it's the blue. What you wrote is blue.
Wait. But we said x is greater than y. Didn't we? Didn't we conclude that X is greater than Y? Didn't we say this was true?
Oh, oh
Didn't
well.
we?
So I picked the wrong one.
Didn't we?
Yeah, I guess so. So X is greater than Y.
So it's D.
Yeah. D, yeah. This
Oh
is
my
it's
God.
a hard question.
Whoa! Number 33. Your brain is completely fried. You don't have a calculator.
Yeah, this is tough.
Oh my God! But I don't know. I'm wondering whether if you just literally calculated X, Y, and Z the normal way, whether that just would have been better, rather than being super clever and making the inequalities.
Yeah, absolutely. Yeah.
So we blew this one. This is a clever. This is
Yeah.
a high, sophisticated PhD way of doing it. Because it's very general and it could be used for inequality. It could be used for quadratics. It's just brought in the general way of approaching this problem, not specific.
Please
to
put
this
your
problem.
signs in there.
Yeah,
So this is
I was doing
this
wrong.
distance
I was
is
looking for a pattern.
1/4 minus 1/7.
I know. No, what I was doing.
Let's be right. This distance is.
Oh, I was totally wrong.
1/3 minus
Right.
1/4.
Yeah, right.
And this distance is 3/7 minus 1/3.
Right, yeah,
Calculate each one.
I was setting it up completely wrong. I'm sure I would have caught that once I started doing it. It wouldn't have made any sense.
So this one is 3/28. Right, this one is 3/28. This one is 1/12. And this one is 9. Let's see, 9 minus 7 is 2. 2/21. And put these in order.
Wow. How are you going to, without a calculator, if you want to compare these, the common denominator between 28 and 20.
Let's see. This is both of these are approximately. So here we could compare these two. And let's see, this 1/12
they're both divisible by
is
3.
equal to 2/24.
Right.
2/21 is bigger.
Right. Yeah.
So Z is greater than Y.
Right. Yeah.
Z is greater than Y.
So this
and then we compare, and therefore we now want to compare Y. Yeah, Z is greater than Y. And then X might be, you never know where X is, right?
Hey, Z is greater than Y.
Yeah.
So they knock this out. Z is greater than Y. Knock this out. Z is, oh shoot.
Z is greater than Y. That means in the order, the Z has to come later.
Wait, so we're wrong?
Than Y. Yeah, you're wrong.
We're wrong.
We calculated that Z is greater than Y. So get rid of those black lines.
So we did it wrong.
Z is greater than Y is true in this one. It's because Z is after the Y in the order.
Oh yeah.
It's true in this one. Z is after the Y in the order. It's true in E and not in D. So we have these three choices. And they're the three choices specified with respect to Z and Y, whereas X. X is either before the two of them, between them, or to the right of them.
Mm.
So you have to make two tests to tell.
Oh my goodness. So somewhere we made a mistake because our work is really, really messy and we're not being methodical.
Yeah. So
Oh
this
wow!
one is
So the operative thing to do on this question is you got to be very organized, unlike us.
yeah.
Oh whoa! So we get punishment. We become small. Oh wait, what should we do? Should we redo it? What time is it? I gotta go soon. Uh, wow! I gotta go in 4 minutes. Oh my god! Someone's gonna call me in 4 minutes. What do we do? Yeah, can you do it real
I
fast?
think we just leave it for our friends to work it out.
Yeah, okay, so don't do it. You gotta.
Yes, but this one you have to work out, where you have to real work it out. Oh, I think you get a sense of you could, that would, it's like this, sir, where you have to do the arithmetic by hand or not on the SAT anymore.
Yeah,
So to see what's happening, just do it with a calculator.
right. Yeah,
The key thing is knowing that x equals a quarter minus a seventh,
yeah,
etc. You write out those three expressions, put them in a calculator, and compare them. Compare the decimal. The calculator calculates them in decimal. They're fractions. They'll be decimals, point zero point something or other, and then they're far enough apart so that the calculator, to the precision of a calculator, you could tell
right.
to put them in order.
So just if anyone finishes this, good luck. You're right. You'll never see this question on the SAT. Mathematical section 5. The answer is D.
Uh-huh.
Wait, we said it wasn't D. So we were wrong. The
Okay.
answer is D. So wait, our initial analysis was correct. Your little analysis here, your little analysis up here was wrong.
Well, see, no one's perfect.
Wow, so we actually did it the fancy way correctly. And then this one was actually wrong.
Yeah. Oh, well.
Wow. Okay.
So Z is the smallest.
Yeah, so our analysis, when we checked it, we made a mistake. We had to make a mistake somewhere. And it was actually on our checking that we made the mistake. Okay, enough. We've done enough damage for today. We've totally crashed. Sometimes happens.
Yeah.
We're not used to the old SAT. But yes, calculate, of course. Okay, everyone, please dislike our videos. We appreciate it. We're basically here to show you how to approach SAT math questions. We come from different backgrounds. We have different approaches. The real question we just did really had only one approach. But still, we fall for different insights into it. Take as many Blue Book tests as you can. We've heard rumors that Blue Book 6 and Blue Book 4, as far as math are concerned, are the closest to the actual SAT, so pay attention to those tests. And practice on anything the College Board gives you. And if you have any, if you want to practice any particular topics, go to the Khan Academy website for digital SAT. They partner with the SAT people, and you can practice on different topics that particularly you're weak on, but also practice on the topics you're strong on, so you get really fast and good at those, so you have time to do the more difficult questions. Okay, everyone, have a great day, and we'll see you next time we meet. Bye-bye.